Hi, this is Maggie. In this video we're going to talk about keyboard events. Keyboard events are generated when the user presses or releases one or more keys on the keyboard. As with mouse clicks, when the user presses a key on the keyboard, two events are generated, a key down and a key up event. If we run listing 8.1, which displays the dictionary of every event that the program processes, and we press a key, we can see the dictionary of the key down and the key up events. Both events tell us the key that was pressed. Now, here the language gets a little confusing because we must distinguish between a key in the events dictionary, the key in the events dictionary, and a key on the keyboard. I'll try to be clear. So the key in the events dictionary tells us which key was pressed. This corresponds to a key on the keyboard. The key down event also has a dictionary key called Unicode, which maps the keys that are being pressed to a Unicode character. Note that the key being pressed and the Unicode character are not necessarily the same thing. For example, I might press the K on the keyboard, which maps to key 107 and Unicode character lowercase k, but if I press both K and a shift key, then the key is still 107, but the Unicode character is uppercase K. The keyboard does not distinguish between uppercase and lowercase characters, and so neither does the event dictionary key. We can also see something called mod, and we see scan code, which we will ignore. The mod event dictionary key is a number that corresponds to all of the modifier keys that are pressed at the same time as the key up or key down event. We will start by looking at how to process keyboard events, and then we will talk about modifier keys. This program is listing 8.3, and if I run it, you can see there's a blue blob at the upper left of the screen. Now, if I press the arrow keys, the blob will move down for the down arrow key, right for the right arrow key, etc. If I press the space bar, the blob will be drawn permanently to the background at its current location, which you can see if I continue to move it after pressing the space bar. Here's the code for listing 8.3 and specifically the event loop. Here we're processing key down events, but you might choose to process key up events or both key down and key up events, depending on the system you're programming. We'll come back to the modifier keys, which we process here in this section that is commented Control key for double speed. Let's focus first on processing the arrow keys and the spacebar, which is this if-elif block. Be careful when you're writing your event handling code to get your logic right. Remember to use an if-elif block when you're handling mutually exclusive conditions. So if the user has pressed a right arrow, that is mutually exclusive from the user pressing a left arrow. Now, of course, it's possible they might press both at the same time, but I'm going to handle only one at a time in this program. So I've used an if-elif block. That is separate from whether they've pressed the Control key or not. So notice that I handle the Control key press in an if-else statement, and then in a separate if statement, I handle the arrow or spacebar press. I hope that makes sense. I want to handle modifier keys in the same iteration of the loop as I handle regular keys that result in an action. That's because the modifier keys might modify the way I handle the action. But I allow only one action key at a time. Okay, so back to the if-elif with the arrow keys. I look at the event dictionary key called key, and I compare that to the pygame constant for the key I'm interested in. And you can see these constants in the documentation for key. You can see there are quite a lot of them. In this program, after we've confirmed there was a key down event, we then check if the key that was pressed was pygame.kup, pygame.kdown, pygame.kleft, pygame.kwrite, or pygame.kspace, because those are the keys that result in some kind of change of state in our program. And in this case, we move the X or Y location of the blob based on the key. For example, if the user pressed the up arrow key, we subtract 3 times the speed multiplier from the Y coordinate of the blob. The speed multiplier defaults to 1, so our blob is moving at a very slow default speed of 3 pixels per key press. After we handle the key presses, we blit the background to the screen, which clears the current location of the blob, and then we blit our blob to its location. So if we adjusted it by 3 pixels in some direction, the blob will appear to have moved. And of course, if the user pressed the space bar, we handle that by blitting the blob to the background, which makes it a permanent part of the drawing. Now, let's take a moment to look at how modifier keys work. The mod key in the dictionary is a number. If no modifier keys are pressed, that number is 0. But if a modifier key is pressed, then a bit is flipped in the binary representation of mod. So for example, in this table from the book, you can see a few of the modifier keys. We can see left shift, right shift, left control, and right control. If the user has pressed the left shift key, then the bit in the ones place in the binary number is flipped from 0 to 1. If the right shift key is pressed, then the bit in the twos place in the binary number is flipped from 0 to 1. If the user has pressed the left control key, then the bit in the 64's place is flipped from 0 to 1. And if the right control key is pressed, then the bit in the 128's position is flipped. Each modifier key has its own bit. So if the user has pressed more than one modifier key, then there won't be any confusion. If they press the left shift and the left control key and no others, then the ones position and the 64's position will both have ones in them, and all other positions will have zeros. Okay, so how do we use this clever representation? There are constants, of course, defined for each of these numbers, and also combinations of the numbers. These are the kmod constants, and here they are in the pygame documentation. Let's take a look at another table from the book. Here we imagine that the user has pressed the left shift and left control keys, but we only care about the left control key. We use an operator called bitwise and we combine the mod value from the event dictionary with the constant for the key we're interested in, kmod_LCTRL. And if we get kmod_LCTRL back from that operation, then that key is pressed. And if we get 0 back, that key was not pressed. So you can see that in this code. If e__dict__submod and kmod L control equals kmod L control. The bitwise AND operator is a single ampersand. The way bitwise AND works is it compares each bit, one bit at a time, in the two operands. If both operands have a 1 in that position, there's a 1 in the result in that position. If either or both have a 0 in that position, then there's a 0 in the position in the result. Think of 1 as true and 0 as false, and it's the same pattern as for regular logical AND. Now you don't need to actually compare the result back to kmod L control, because not only can we think of 1 as true and 0 as false, but Python and many other programming languages think of 0 as false and any other number as true. So we can just write if edict submod and kmod L control, or whatever key we're looking for. And that's going to be true if it evaluates to a 1 in the kmod L control position and false otherwise. So in listing 8.3, we're checking to see if the user has pressed the control key using code similar to what I just mentioned, and we're setting a speed multiplier if they have pressed it. Remember, this is multiplied by our 3-pixel speed if the user presses a key. So if the user presses a control key while they're pressing an arrow key, the blob will move twice as many pixels. I recommend you try some things with listing 8.3. Change the keys that the user presses to move the blob. For example, change to ASWD. You can process more than one modifier key as well. For example, you could allow different modifier keys to change the speed by different amounts, or you could have one modifier key cause the blob to move in the opposite direction from the arrow press, or you could have a modifier key that prevents the blob from being blitted to the background if the user presses the spacebar. These are just ideas to help you practice processing modifier keys. If you're feeling ambitious, see if you can figure out how to get the blob to move continuously as the user holds a key down, rather than requiring the user to press and release the key each time the user wants to move the blob. You might want a Boolean for that. Once you're able to make these modifications to this code, you're ready to move on.